it's given that a circuit is defined by this differential equation. We need to find the time constant of this one, and then V infinity. When we look at this differential equation, if we write a similar one, we can see that this is like this. This can be V over R, and this can be I. So basically this one is like this one, current source, a resistance and a capacitance, like that. And the current source value is 10, resistance is in this case 1 ohms, and the capacitor will be 4 farad. Now what has been done is the KCL here is written, the current is going in this direction and these two current are coming here. So the capacitive current is given by C dV over dt, and the resistance, the current through the resistance is given by V over R, but this is just V, so we have written V R is 1 essentially, and this one is the current source, which is 10. So if we now we need to know the time constant. The time constant will be RC, and of course R is 4 here, C is R is 1 here, and C is 4, so anyway the other way around, so that's 4, that's the time constant. And the V infinity, which of course will be just this one will become open. So initially this one is a short circuit and then it becomes open for the DC condition. So of course the V infinity will be just this resistance, this current will finally will be here, because in the end the circuit will be like this one will be an open circuit, so the voltage here will be just 10 into 1, which is 10 volts. That will be the voltage here. If we want to write the current through the capacitor, which is IC, we can say I transient plus I steady state. I steady state will be 0, and I transient is constituting of, let's say, I0. This is the current at initially, and this one is like that. So initially at t is equal to 0, I will be, of course, the capacitor will be initially short circuited, so the entire current will flow through the capacitor, and t infinity I will be of course 0. So this one is 10 and this one is I naught e to the power minus t over RC. Of course at t is equal to 0, this one is becoming 1, so I naught is 10. So, and this is a decaying current of essentially, it will decay with this rate. At this rate it will decay the capacitive current, and the voltage will be again capacitive voltage VC 1 over C I dt. So that one is 1 over C, and the integration will be 10 here, the negative here, and the 4 will come here, and e to the power minus t over 4 plus the new integration, the integration constant there, so VC. So this one is minus 10 into 4, and capacitor is 4, so e to the power minus t over 4, and then C1. So this is, the negative is coming because of this one, and the capacitor voltage at t is equal to infinity, Vc will be, of course, Vc will be the voltage across the resistance, and so that's 10. So we can write Vc, this is negative 10 e to the power minus t over 4 plus C1. So at infinity, t is equal to infinity, this is 10, this one is becoming, of course, t over RC, so this part will become 0, and then C1. So of course what will happen, I haven't plugged it in, so in infinity, so this will become 0 plus C1 10, so C1 will be 10, and VC as a result will be like that, which is, so initially the voltage across the capacitor is RC, as 4 actually RC. So initially the voltage across the capacitor will be 0, and at infinity the voltage t is equal to infinity, or the steady state voltage will be 10. So essentially that's what it will be, like that one. here, and it's the same voltage actually because it's a parallel branch.